background, the product's called To Go No Code Mobile. Basically, what it's been designed to do is to produce what we refer to as a mobility layer, effectively sit the layer on top of underlying applications and enable it to be accessed and used on mobile devices. So the whole purpose of To Go is effectively to try and create that capability of mobile use. And we make a number of claims for this. Basically, one of the things to understand is that we literally could deliver mobile capability on any application, assuming that we can actually find a method of connecting our technology to the underlying systems. And it's regardless of who that vendor is or the state of the development. So, we can even incorporate sort of legacy applications. They don't need to be SaaS-based. They don't need to be the latest and greatest. And we do it all within one app and without any need to re-engineer or redesign or develop anything. So the strong message for us is that this is actually a fairly straightforward application if you actually understand how it could be applied. But obviously, I'm more than happy to dig into how does it actually work. So a couple of key things first before we go too far into it. Very rapid implementation. As you'll see, I share an infrastructure slide with you in a minute. There are a number of bits to the solution, but the client itself downloads out of an app store within seconds. The server software installs in about 20 minutes. The configuration of the server in order to actually get it to connect to the underlying application varies depending on the nature and the style of the application, and literally can be anything from 15 minutes to a few hours in terms of actually getting it done. But the whole key here is it isn't measured in weeks, months, etc. It's actually very, very rapid. It's fully data secure. There's no data stored on the device. So if the device is lost or stolen, no data goes with it. We often use the phrase, this is a bit like Netflix for business, because what we're doing is we're streaming pixels to the device and then using the device basically to track interaction. It's also quite important to stress that any of the work that is being done is actually not being done on the device, not being stored on the device. It's actually being stored back centrally in the data centers on the various servers that are actually in use. We claim it's very intuitive. It hasn't got a web browser interface to force you to try and use a Windows browser on a mobile device. We've written our own native UI, which I think you will see shortly is pretty easy to navigate, fairly intuitive, driven by icons and thumbnails, and giving us effectively full screen capability when we're actually working within the application. We've focused our development effort not so much on the question of can we make it mobile, but can we make it useful when you've made it mobile? And so we've focused very heavily on how to make users highly productive with things like specialized keyboards. When we deploy this, for example, I'm sitting here with my iPad. I can have a keyboard capability on my iPad that's got control keys and function keys and all sorts of strange keys built into these keyboards to enable me to actually work with an underlying application that recognizes it. Equally, we built a whole custom gesture library to enable us to actually drive this with gestures as opposed to having to type things, through to voice controlled data capture. And that's actually something that we've been talking quite a lot of in terms of the NHS, so we'll go back over that for you later. And in comparison, it's really quite inexpensive. And that's because we're not asking you to throw lots of hardware at it. We're not asking you to update all the latest to greatest versions of the software you need to use. We're not asking you to develop lots of mobile apps to be able to actually get them to run on mobile devices. And lastly, our approach in terms of pricing this, as I've shared with David in earlier conversations, is because we own this 100%, we can effectively take a view that says, let's work with Atos to work out a pricing process that's appropriate as far as the clients, Atos and ourselves are concerned. And that could be of any form. So the background to this is that when we first started working on this, we looked at the question of what is the challenge with trying to go mobile in terms of some of these enterprise level applications. And predominantly the challenge is that most of these have their origin prior to the explosion of mobile technology and typically have not been designed for mobile use at all. Although obviously a lot of them have recently been updated in terms of making SaaS versions available of some of these applications. So the big barrier that we were dealing with is non-access, if you like, from a mobile device. And there's a few things just to share with you, some of the background as to why we did this. We talked to Gartner a lot in the US. Gartner came up a couple of years ago with the fact that the demand for development was going to outstrip the ability of IT departments to deliver it. And we are confident that that is actually true. There is a huge demand out there. They also went on and did a study that took a sort of archetypal US organization and figured out they would need over 2,000 mobile apps to reproduce their in-house capability of all their systems they actually had in-house. And Kinvey came up with a study that showed that the average mobile app takes about 18 weeks to develop and costs north of $250,000. So quite clearly 2,000 times $250,000, huge amount of money. Not suggesting anybody will actually build 2,000 apps, but that's the scale of the problem. And then, of course, everybody knows that we've moved into this glorious world of cloud and SaaS. But intriguingly, there's a comment from SAP that says SaaS is not mobile. And what they mean by that is SaaS is designed typically for use with mouse and keyboard, laptops, desktops. It really isn't engineered specifically around mobile use. And that's the clear direction for us. So we focused all of our energy, if you like, on trying to make the interface here intuitive, trying to make it easy to navigate, and trying to make it user productive, as I said. Now, when you look at the question of implementing mobile technology into something as complicated as the healthcare area or pharmaceutical businesses, you have to deal with a number of different aspects to that. And the diagram here is really just trying to replicate some of those issues and some of the things that we would say to those various people about what this solution delivers. So for IT, it's all about how quick we can implement it. It's very, very rapid. For users, and I've chosen the word nurses here, but for users, it's entirely familiar. We're not changing anything in terms of the way they do their work. They're working with familiar interfaces that they're used to using on desktops and laptops. As far as developers are concerned, they might be slightly miffed because there's actually no code required at all. So they've got no major challenges involved in getting this implemented. From a security perspective, we get an immediate tick in the box as soon as we actually tell everybody there's absolutely no data on this device. So, we really do not have a security issue around accessing some of these systems. Financially, very high ROI, relatively inexpensive implementation. So in short, we should end up with a really efficient process in terms of clinicians being able to actually work with the system and being able to see more patients, take less time doing things, and so on. That's fundamentally what we developed. That's why we went about this, not specifically in healthcare, but more commercially, to try and bring some of those benefits through. And we developed this technology, as I say, which we call To Go, which effectively enables us to use the mobile devices as a window in onto these remote systems and to then focus on tracking the user interaction with those applications. So the solution is actually made up of a number of parts. Very quickly, those are the client, and the client's actually available for both iOS devices and Android devices. Our validation server, which sits up in Amazon and effectively ensures that any client device needing access to the system needs to be pre-authenticated, needs to be validated first. The validation process is very simple. We send the user an email, ask them to open the email on the device, and in the process of opening that email, we actually suck out some of the technical information about the device. For example, its IMEI, its resolution, certain other technical characteristics that we need to understand what this device is. And we assign it a license. But in the process of assigning it a license, what we also do is we download to the device on a temporary basis the user's profile. So what we're actually saying there is, okay, we recognize we have got a valid device, but we've got a user that's using the device. And so what we need to have an understanding is who is the user using this device. So that brings in this to-go server that you can see highlighted in the middle. Server software capable of running on a variety of platforms, but typically on Windows servers. And what it's actually doing is it's handling requests for access by the users. The first thing it does is it actually pops up and asks for users to log in. Users would provide their credentials. Their credentials are encrypted, burst across to the to-go server where they're decrypted. We don't do the authentication ourselves. We simply connect our to-go server to whatever the in-house authentication system is. So let's assume for a minute it's Active Directory. We send those credentials to Active Directory and we look for a success token to come back. Once we've got that success token, we use that effectively to emulate that user in the communication with any and all of these applications that are sitting inside the network. What then happens is our to-go server will actually then deal with the vision of that application. Let's assume for a minute we're looking at a patient record system. We've effectively selected a particular patient. We have a screen full of information for that patient. This is then captured by our to-go server, again, pixelated, encrypted, transferred across to the client device where it's decrypted and with an instruction to actually visualize it on the screen. At that point, our client then kicks in with tracking the user's interaction with that remote image. And we've implemented, as I've said, things like custom gestures, specialized keyboards, a very slick pinch and zoom capability, dynamic navigation and so on to make that interaction as intuitive as we possibly can. And it's this backwards and forwards streaming process where what we're moving all the time is pixels as opposed to packets of data and storing packets of data that enables us to actually make this claim that we're fully data secure. So I'm going to very quickly go through this because this is actually just some slides that actually talk about the client and its method of operation. But what I've actually got rigged up here is a remote camera and my iPad. So I'm going to try and switch over in a minute and give you, if you like, a live demo. But just so you understand what you're about to see, our navigation process is simply this toolbar you can see here on the left-hand side. So icon driven. If we select to actually log in, we'll get a series of application icons to give the user an indication of what it is they're actually allowed to access. You'll forgive me for a minute, all these applications and the demonstration I'm going to show you do not have any healthcare applications in them at the moment, but conceptually, think of these as being healthcare applications. The user taps on an icon. Let's assume they're going to tap on the click view icon. What they get is full screen click view in the background. And effectively, they can then work on that click view system, as you'll see in the demonstration. Whilst they're doing this, however, what they're actually doing is they're running a session on our to-go server. they may choose at that point to actually go somewhere else. So, for example, they can tap on the favorites button. And what that will then give them is an access to any of the other applications that they've been working on. These are effectively frozen sessions. By tapping on, in this example, the dashboard at the top, it freezes the ClickView session and unfreezes the dashboard session, with the result that the dashboard appears instead of ClickView. And now you can actually work within the dashboard. Historically, the way we've worked is we've always worked on this singular session process. But in a conversation with West Suffolk Foundation NHS Trust, Mike Bone, the CIO there, introduced the concept of what I believe are called trusted assessments, and the problem of clinicians getting a correct, holistic view of a patient across a series of disciplines. And therefore, what we've actually looked at is, could we run this slightly differently? Could we, for example, have multiple live sessions running on the device and giving us the ability effectively to look across these systems, to look across these disciplines, with each one of them effectively being able to be worked with, to be interrogated, and giving us the ability, therefore, to get this visual picture of a patient's state of health over time and by discipline. And that effectively is what we call dynamic multiple concurrent views. But I understand there's a different term for this being considered in NHS terms. And that, in essence, is what we are talking about. That's the capability, if you like, that we have within the application.